Welcome to today's part of this SPSS methodology, this time with a unit on factor analysis. What can we understand with or under factor analysis? Factor analysis works, well, in some ways similar to cluster analysis. The idea is here, consider I have different variables which describe similar concepts. For example, if I have a relatively complex concept like sustainability, I'm not able to just use one question to get a good scale for how sustainable someone acts. So I need more of those questions, and all of them will, well, at least in some part, deal with the concept of sustainability. But they're all slightly different. So in the end, I would need to find a way how to summarize all of those different questions, all of the different variables, into one single scale, for example in this case for sustainability. That's where factor analysis comes into play. So here I have prepared a data set, 14 different questions, and if we take a look at the labels, they are all in some way related to which type of clothes I buy. Here, when I hear that a new type is available, directly interested in buying it, love to buy clothes in general, like to buy clothes by new designers and brands, know about new designers and brands, compared to my friends I own much more clothes. So it's all different aspects about how active I am at getting new and different clothes. So it could be assumed that those questions have something in common. So if we want to prepare this, we could start by simply running a short correlation table. So we select all of those variables and run a correlation. And we can see that some of the variables, in particular if you take a look up here, like the first 4, they are all highly correlated with each other and also report large correlation coefficient or comparatively large correlation coefficient, while with all the other variables they might be correlated, as is the case here, here or here, but the correlation coefficients, the strength of the correlation, is significantly smaller than in this set. So it stands to reason that perhaps those 4 measure one certain aspect of buying clothes, whereas the other parts measure significantly different aspects. That's what we're going to go into detail with factor analysis with. So factor analysis tries to reduce those 14 different variables to more compact factors, more compact variables and concepts. Thereby we try to reduce our dimension, so we find factor analysis under dimension reduction and factor. So we click here, and then we do something similar if it's with the correlation. We just select all the variables and put them under variables. So we could just start with the output. However, let's do something else beforehand. If we click on descriptives, here we could select the last point, the KMO, Kaiser-Criteriom, and the Bartlett-Test of sphericity. We need to use this to know whether we can actually use our data set for factor analysis, whether the whole set of variables is actually suited to be used in the context of a factor analysis. So this is the first part we check. Then if we turn to extraction, here we can check the scree-plot as a second way to extract different factors. And, well, the standard criterion on selecting the number of factors is the so-called Kaiser-Criteriom. This is the number of factors to be extracted is the number of eigenvalues greater than 1. If you're not happy with this criterion, you could change it here to eigenvalues greater than any other value, or you could directly fix the number of factors to be extracted. So this is the part here. In this case, we just additionally check the discrete plot. And we could go to rotation. In this case, we will just select the Varimax. What the Varimax actually does, I will explain when we see the output. So click on continue here as well. Then we could click on scores. The scores menu is what should we do with the result. If I get my new concepts, my new variables, my new factors, what do I want to do? And here I have the option to say, okay, calculate for each case the score with each new factor and save this as a new variable. So if I have like 3 different variables measuring sustainability, I get one factor on sustainability, I can here generate a new variable called sustainability, which is then the summary of the other 3 inputs. Here I will skip this and instead go to options. With options, we have here the possibility in our factor loadings table to suppress small effects. Here it's selected as everything below 10%. We could go up to 20-30%. I wouldn't go too high, but 20-30 would still be within reasonable bounds. So let's select here something in between with 25%. Click on continue. Then we are finished and we can click OK. So if you recall, I said we need the KMO and the Bartlett-Test to check whether our data is actually suitable for factor analysis. And here the first one, Kaiser-Meyer-Alkin measure. This is a measure somewhere between 0 and 1. The closer to 1 this value is, the better suited my data set is. So here with a value of 0.74, that's actually decently enough suited for factor analysis. Could be better, but it's still good enough to run a factor analysis on the data. And the same thing is said by the significance level of the Bartlett-Test, which tells us as well if this significance level is smaller than 5%, my data set as a whole data set, so all the variables, all the 14 variables taken together, are suited in the context of a factor analysis. However, it always could be that there are single variables which are not so well suited. And that's where I can use the so-called communalities. The communalities tell me which part of the variance of each of the variables can be explained by my extracted factors. So at this point I do not know how many factors I will have. This is something which follows further downwards. But I know here with the extraction part that the factors which I use, so the concepts I use, can explain roughly 2/3 of the deviation of the first variable. Roughly 95% of the second one. Roughly 61% of the third one. So to assure that each variable is represented decently enough with the factors we extract, we say variables is only suited for factor analysis if its communality after factor extraction is at least 50%. So the values here, the communalities here, need to be larger than 0.5. If we just scroll through this table, we can see here this is actually the variable with the smallest communality. So here only 50.1% is explained with our factors. So this would be like the worst of all the variables to be used in this case. Still it's larger than 50%, so we could still keep this variable in our data set. If this would be too small, like 20%, 30%, we might consider erasing this variable from our data set. So this allows us to go into more detail and not only have like the one test for the whole data set as one. So aside from this, okay, we know our data set or single variables, they are actually usable for a factor analysis. So let's go to the second step. How many factors should we actually use? And for this, we can use this table on total variance explained. And we see here in the second column the eigenvalues. I said the Kaiser-Criteriom says extract as many factors as there are eigenvalues larger than 1. So here we have like this one is larger than 1, that is larger than 1, that one is larger than 1, and the fourth one here 1.098, barely, but it's still larger than 1. So this part would tell us extract 4 different factors. However, there should be a second part which needs to be fulfilled. And the second part means the total variance explained by the factors, so the cumulative variance explained by the factors, should be as a minimum above 50%. This is similar again to the communalities, and better somewhere around 2/3 or above. Okay, here we only have roughly 63%. It's still good enough for our example. In reality, you might start becoming skeptical here, might try to change the data set a little bit before running this analysis again. However, here for didactical choices we stay with this example. And if you're not so happy with this result, which might also come from the fact that this value as well as this value, they are both pretty close to 1. So this might actually interfere with our decision. Okay, before we go to the second step, which could corroborate this or be against this way of this solution, why are we selecting the number of factors according to the number of eigenvalues larger than 1? Well, here we have 14 different questions, 14 different components. If we were to add up all the corresponding eigenvalues from the covariance matrix or correlation matrix, we would actually get a value of 14. So each of the different factors provides an additional 1 to the overall total. So if we can then say, if I have the first component, this component has the explanatory power of almost 3 full variables. The second one still has the explanatory power of roughly 2.5 full variables. So whenever I have an eigenvalue which is larger than 1, I can explain more than one single variable. So the factor can explain more than the original components. And that's why I go with those factors, because they can explain more than the original variable. And if the overall part of variance I can explain also exceeds a certain level, well, that's a big advantage for me. And well, the amount of cumulative variance also is the same thing as if I were to add up all those eigenvalues up to a certain point and divide them by 14, the number of observations. So here, if I add up all those 4 eigenvalues, divide them by 14, I would get those roughly 63%. So far for the background on this. If you're not happy with this Kaiser-Criterion, the alternative would be using this scree plot. This was the one we extra checked. The scree plot can be interpreted similarly. We could take a look here where there is the sharpest break in the scree plot. In some cases it's also called elbow criterion. So where's the elbow here? In this case it's not so clear cut. The elbow could be any of those 3 points. If we assume it's that point here, so this would relate to component number of 4. And then we say the scree plot criterion says the number of factors should be where the largest or the most significant break occurs. So here the 4 minus 1, so the 1 to the left. So here this criterion would actually motivate for us to select only 3 different factors. So this here is more or less even. It could however also be 4, could also be 5. This is actually the problem I mentioned up here, because these two values are pretty close to 1. It could be only those 3, could be that one included, so 4, it could also be this one included as well, giving us 5. So in this case it's not as clear-cut as we would hope. However, well, the standard criterion is the Kaiser-Criterion, so here we continue with 4 different factors. Then the next part we get, that's here the component matrix. The component matrix shows us which of the different questions is assigned to which of our new factors. So we have 4 different factors, and that's the weights. There are some free spaces here, because if you recall, we suppressed all weights, all values smaller than 25%. So all the free spaces, they had an entry, but the entry was smaller than, or in absolute terms, smaller than 0.25. And you see here all the values are actually, absolutely speaking, larger than 0.25. However, well, this is not as clear-cut as we would like it to be. Okay, this one is clearly factor 2. Here I could assume this is more factor 2 than 1. But what about this one? What about those ones? That's actually pretty problematic. And to get a better result, a better assignment, that's the point where the so-called rotation, the Varimax rotation, comes into play. The Varimax rotation tries to rotate to find a different alignment of our factors. So you can imagine this as our 4 factors being 4 different axes in a system of coordinations. The Varimax rotates this system of coordination so that the assignment becomes way clearer, one hand, and Varimax vary from variance. The variance, meaning the difference between the different factors, becomes much more distinct. So the factors each other are way more different from each other. Okay, considering this, we can see here, this is way clearer than one before. Okay, there are still some with 2 assignments, but usually it's relatively clear which is the bigger, the stronger effect. This is the only one where we have some problems. Premium designer clothes provide a much better quality than non-premium ones. Let's return to the very beginning. Up here we see this is still 0.622. In some cases it could be the case that a variable which cannot be assigned decently enough, also reports a smaller communality. In this case, luckily it's not the case. The variable I love to buy clothes that allow me to achieve a new look here is relatively clearly assigned to factor number 3. Okay, so far so good. Sorry, that's the wrong one. That's the rotated version. So it's still here 3. There's some part here as well, but it's not as problematic as, for example, this one. Okay, so far so good, but at this point we only know we have 4 factors. What we do not know what those 4 factors actually represent. And that's usually the next step. In this case, we would have to go and take a look which of the questions, which of our components actually load pretty high on one of the components, and then think about what those questions actually have in common. Let's select the part 3 because this is relatively clear. Here we have this one. Good look can also be achieved with non-premium, non-designer clothes. This is on good look. I love to buy clothes that allow me to achieve a new look. Focus new look. By using premium designer clothes, I can better develop my own identity. So this is about my own look, my own identity. So we could give this here like a name, look identity. If we then turn to the first one, so here factor 1, compared to my friends, I own much more clothes. I'm among the first of my friends that is concerned with fashion trends. I'm among the first of my friends to buy new designer clothes. If a friend tells me about a new trend in fashion, I would directly like to try it. So those ones, they are all about I'm one of the first ones. If I hear about this, I would directly like to try this. So this is something like a first mover. He sees something new, he directly tries this. And this is represented also by him having way more clothes because he's the one who tries all the stuff which actually is new. So this could be called, like as a factor, first mover, first adopter, early adopter, something like this. This we would have to do for all the 4 different factors. So we need to give it a name so that the variable, which potentially later on is generated, also can get a decently enough new name. So this is basically the first part, or the main part, in the context of factor analysis. This could be accompanied by 2 additional aspects. We could either run, as this is only an exploratory factor analysis, we could accompany this with a confirmatory in the end. So we basically test whether the structure we assume here to exist, the assignment to the factors we assume here to be, could be enhanced upon, confirmatory thing, or we could take a look how this result could actually be represented in a nice diagram. This, however, is way easier if I only have like 2 components, also from the representation point of view. But if you want to do something like this, you would go to factor analysis, and then we have under rotation here the loading plots. If I select loading plots as well, click OK, get the same result as before. Here the rotated solution, this one, and here, well, as I said, this is not so clear because here he tries to at least represent the first 3 factors. This is only really nice to be used if I only have like 2 factors, but still up to 3 factors he tries to represent. He shows us which questions are actually close to each other, so giving us again an idea in how far they could be assigned to the same factor, because in this case they are close to each other. Well, this then finally concludes this section on factor analysis. I hope you enjoyed listening to it and learned something from this section. If you want to see more of this type of videos, feel free to visit the rest of this SPSS methodology. Until then, see you and goodbye.